Well, I'd like to start things off by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today we're going to take a look at the newest release in fischertechnik's line of simulation models, and that is the Agile Production Simulation, also known as APS. We'll refer to it as APS throughout the presentation. Now, this new model is designed to demonstrate how the current challenges faced in production and logistics planning can be addressed, and it's designed to incorporate the best features of some of the previous fischertechnik models, along with many new cutting-edge innovations. So before we get into the focus of the presentation, I'm going to provide you with a bit of background on fischertechnik and its products and what exactly it is. Now, the model we're examining today is one of the most recent additions to the Fisher line of industrial simulation and training models. And these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. Now, the line of fischertechnik simulation models consists of a series of pre-assembled small-scale models which are designed to replicate both in appearance and in function various automated robotic machines and systems that you would commonly find in a commercial manufacturing setting. The fischertechnik company has been creating tools for teaching students of all ages about technology and how things work for 60 years now, all based around their unique building system. Now, what makes this building system unique is that unlike other popular construction systems where the components are designed primarily to stack, in the fischertechnik building system, it was created with more of an engineering mindset. Now, as you see the example of the core building block on the screen right now, this was designed to enable attachment from all six sides. And because of this, it allows for almost limitless design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method. And the hundreds of different parts available will help technical builders to address very specific design needs. The fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography. This was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices used in building construction. Now, up until very recently, they had also produced numerous components used in the automobile assembly process. These days, they are also known for providing consulting services to companies who wish to employ state-of-the-art manufacturing processes, so you can see the new APS model as being in many ways in line with this strategy. Now, many people are most familiar with the fischertechnik line of construction sets, and the focus of these building sets, whether those intended for the retail market or for classroom use, has always again been on helping to foster an understanding of technology. The sets designed for use in the education sector are most often focused on a specific subject area that falls under the umbrella of what is now commonly referred to as STEM education. These sets address topic areas such as mechanics, pneumatics, robotics, renewable energies, things of this nature. Now, typically, students using these sets in the classroom are asked to build a progression of models using the fischertechnik system, and then they perform various experiments and projects which will allow them to explore and understand key aspects of that particular subject in a hands-on manner. Now, the line of fischertechnik simulation solutions, which of course the model we're looking at today is one of those models, these are something much different. Again, this line of simulation models these are not kits. They are pre-assembled small scale models, which again are designed to replicate in appearance and function various automated robotic machines and systems. Models in the fischertechnik simulation line will include, among other things, things like conveyor belts, multi-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models, which will focus on specific automated processes, fischertechnik also offers numerous variations of an integrated factory simulation model. Now, in the case of these factory models, they consist most commonly of four or more individual workstations, such as, for example, a vacuum gripping robot, a high bay warehouse storage, a multi-processing station with an oven, and a color or a sorting line with color detection. And these four models, in the case of the factory setup, are designed to work together as one self-contained material cycle. Now, other variations of the factory will focus on the idea of Factory 4.0, which utilizes IoT in the form of controlling and monitoring the actions of the factory from a web-based dashboard. Now, as we have a full-scale webinar presentation discussing each of these models in detail, I'm not going to touch on the other models here, but I would strongly encourage you to attend an upcoming presentation if you'd like to know more. We do a monthly webinar where we discuss all of the models in the line, or of course, you can reach out to me for more information. I will give you my contact information at the end of the webinar. Now, before we begin our overview of specifically the Agile Production Simulation model, we're going to very briefly outline some of the advantages of working with fischertechnik solutions. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. Models, once again, are designed to realistically replicate in both appearance and in function common automated systems, things such as conveyor belts, sorting machines, robotic arms, and more. Their compact size, they're not only ideal for use in the classroom or for in-office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. The next factor, and a very important one, is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. The majority of the models in the fischertechnik simulation line, including, of course, the Agile Production Simulation model, which we're looking at today, these are 24-volt models, which are designed specifically for use with the latest industry standard PLCs. Now, while the APS model that we're looking at today does already include all PLCs and necessary components within its scope of delivery, so again, when you purchase the APS model, you're going to get everything you need essentially. But in the case of the other fischertechnik models, they're designed to be used and controlled using your PLC of choice. So whether you like Honeywell or Mitsubishi or Siemens, you have that option to use different PLCs with it, as well as, of course, the programming language you prefer. And this, again, refers to the other models. Again, the APS we're looking at is going to essentially be pre-programmed. Now, again, these models are designed specifically for use in higher educational lab settings and also for use in industrial and commercial training facilities and classes. Now, there are also a handful of models designed for non-PLC users where the control is instead facilitated by using a proprietary fischertechnik controller, and that same controller that's used in their line of educational robotics. And again, if you'd like to know more about those models, I strongly encourage you to attend our other presentation. Now, finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you're going to probably notice pretty quickly that the entry point for many of these models can be quite high. Fischertechnik simulation solutions, on the other hand, start at just a fraction of that price, as well as, again, being compact, realistic, and high-quality learning and demonstration tools. Now, while admittedly the APS that we're looking at today is the high end of the fischertechnik product range, it still offers significant value in terms of what it allows you to address for a still very reasonable price point, and you would be very hard pressed to find a truly comparable solution available at any price point from any manufacturer. So with that being said, let's now move our discussion specifically to the Agile Production Simulation model and discussing what the term Agile Production means and why it's important. Now, here's a slide that I have used in several of the other fischertechnik focused webinars that we present, and what it shows is an early version of the Henry Ford style production line. Now, the Ford production line was in its own time a very innovative thing in that it allowed for the streamlining of production back in a time when the focus was on efficiently producing a large quantity of the exact same thing. Now, in this case here, workers along the assembly line each focused only on a specific part of the automobile production process. For example, maybe they were focusing on installing a specific component or making a certain adjustment to the vehicle before the vehicle was then moved a little further down the production line, where the next worker in line would, of course, again, perform the specific task for which they were being charged with, and so on and so forth, until the assembly of each model was completed. Now, again, when the goal is to produce a large quantity of the exact same thing, this is a great method and it works really well. Of course, things are no longer quite so simple, and there's a lot of good reasons for that. Product customization must be considered, as well as the larger number of assemblies and components that need to be used. Likewise, the increase in customization options which are available. And on top of that, product life cycles are also much shorter now, with an increase in overlapping product launches and product mix. And flexible manufacturing requires an increase in logistics processes. Now, to summarize, industry must now deal with smaller batch sizes during the production process and increasingly complex processes. This requires companies to better synchronize production and logistics and to make investments in cutting-edge automation equipment and processes, and again, to be as efficient as possible. As an example, let's consider the production of a modern automobile, and we'll use the example that's shown on the screen right now, which is the BMW 3 Series. The manufacturing process for this model must be set up to efficiently and cost-effectively address the 18 different engine options available to consumers, as well as the 5 different equipment packages and 70 different individual equipment options. Now, clearly, the old school Henry Ford style assembly line that we saw before, which again was designed to quickly produce a high quantity of a single specific model, is simply not going to work for this purpose. And it's with this in mind that industry has increasingly transitioned from the assembly line production method we saw to begin with its rigidity and constraints, instead to methods such as the matrix production model, which eliminates the fixed time cycle and sequence of processes, or fluid production models, which also allow for an unlimited number of assembly scopes per station. The most notable benefits of incorporating such agile production methods are in the area, of course, of flexibility. And this includes the increased flexibility in production processes, being able to off customer specific mass production while avoiding overcapacity, and also reducing lead time through a mix of different derivatives. An additional benefit is being able to produce goods as specifically dictated by the wants and needs of your customers. Also AI, and in addition, this innovative new model also includes a digital learning platform. Now, here is a quick look at the full factory. This is what you would be receiving if you purchase the APS model. Here you get an overview of what the whole factory looks like. So essentially, companies with an eye to the future, again, rely on automation, modularity, artificial intelligence, and agility, all to help them remain competitive. So, in order to help promote these topics in industry and in research, students, apprentices, and employees each require a clear awareness and understanding to enable them to deal with these complex issues. And this is where the fischertechnik Agile Production Simulation model would come in. It's designed to simulate processes such as quality assurance using artificial intelligence, AI. It includes the functioning of a driverless transport system, and it also replicates automated processes on a small scale from the receipt of goods into the system to modular production to quality assurance. The model includes several features not previously available in the fischertechnik simulation line, including an automated guided vehicle, as I touched on before, and a six-axis robot. Now, the accompanying didactic materials will help to translate the hands-on simulated processes into future skills for both students and teachers. And in addition, the digital twin of the model helps to significantly intensify the learning experience. Now, while we do have a fully narrated video of the factory in action, which I'm going to share with you in a little bit, I first want to provide you with a brief overview of each of the workstations or modules, beginning with the section where the incoming and outgoing goods are placed, which is referred to in the manual as the DPS, or Delivery and Pickup Station. Now, this is the module that you see on your screen right now, and it is, of course, where the work cycle for the materials begin and end. So essentially what you have happening here is the raw material, or in this case, one of the cylindrical work pieces that you see underneath the gripper right now. The workpiece enters the material cycle when it's delivered by hand to the goods receipt slot. And from the goods receipt slot, it's picked up by the six-axis robotic arm with a vacuum gripper. The the workpiece is first positioned on the color sensor, after which it is encoded by a C reader. The six-axis robot located at the DPS station then places the workpiece on the automated guided vehicle, or AGV as we'll sometimes refer to it, for transport to its next destination or station. I should mention that the DPS station also contains the central control unit, which is a Raspberry Pi, and the environmental sensor, which helps to measure the different environmental conditions in the factory. This is going to be things like the lighting and the temperature and air quality and what have you. Now, there's also an integrated movable camera at this station, which can be swiveled in two axes to provide an insight into the entire factory via the fischertechnik cloud-based dashboard. Now, at the end of a cycle, of course, as much as the workpiece begins its journey in the factory here, it's also eventually delivered back to the DPS station by the AGV after it's made its round of whatever workstations it needs to go to. Now, typically the next stop for a workpiece after the goods receipt is usually the high bay warehouse, although, because again, this is an agile production simulation, the order of processes can be changed if there's a need for doing so. But in any case, let's just play along. The high bay warehouse contains 9 slots for workpieces. It has its own stacker crane and its own vacuum gripper that picks up the workpiece from the back of the AGV after it's docked at the docking station, and it hands that workpiece over to the stacker crane for storage. The workpiece is placed in a workpiece carrier tray for storage. Retrieval is done according to the first in, first out principle. After it's done at this station, the next module we're going to look at is the drilling station. The drilling station consists of a docking station for the AGV. Again, all of these workstations will have a docking station for the AGV as it moves the pieces around. It has its own vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the drilling head. Now, after a simulated drilling process has been performed, the workpiece is then transported back on the conveyor belt, back to the gripper robot. And again, the gripper robot picks up the piece from the conveyor and places it back into the AGV. And this brings us to the milling station. Now, on a side note, I do want to mention, because I haven't touched on it previously in the presentation, but because it's so prominent in this picture, you will notice that what you see here is that the model is already pre-wired to a Siemens S7 1200 PLC. I want to mention that the PLCs have been pre-programmed. We're going to touch on this a little bit more later, but you will see that each of these workstation sections has its own PLC. Anyway, continuing along, much like we've seen at the previous stops, the milling station consists of a docking station for the AGV. And once again, the AGV will dock at the docking station. A vacuum gripper, the station, of course, has its own vacuum gripper again, picks up the workpiece from the AGV, secures it, and moves it from its storage area onto a conveyor belt, from where it is transported under a milling machine. Here, the milling of two pockets is simulated. Now, after this process has been completed, the workpiece is placed onto the conveyor belt, transported back to the vacuum gripper at this station, which again, this vacuum gripper places the workpiece back onto the automated guided vehicle. And next station we're going to look at is the quality control with AI module. Now, with the quality control station, once again, a vacuum gripper picks up the workpiece from the AGV, places it onto a conveyor belt. Next, the workpiece is transported underneath a camera where the workpiece is scanned. And here I should mention that the workpieces used with the APS factory come in three different colors, as you probably noticed, red, white, or blue. And they can have one of three possible machining features pictured on there. So you could either have features for drilling, milling, or drilling and milling, as well as it can have possible fault patterns. So essentially, when the camera scans each of these workpieces, the workpiece is classified using trained artificial intelligence, or AI. So depending on the color, the feature that's imprinted on the workpiece, and the fault pattern that may or may not be imprinted on the workpieces are then either placed back onto the AGV if they've been deemed as being acceptable, okay, or they're sent to a reject container if they're instead analyzed as being not okay or defective. And just to provide a little more information on the AGV, which transports the workpieces from one module to another, each AGV is controlled by a fischertechnik Robotics TXT 4.0 controller, which has been pre-programmed using Python. The AGV is a track-bound vehicle that follows the printed black lines, which you've probably seen on the factory floor here, or these tracks here, it again uses using ultrasonic sensors to help it detect obstacles that might be in its place. The vehicle has omni wheels, which allow it, of course, to move in all directions. It has two buttons and a photo transistor to help the vehicle dock to each factory station. The AGV does receive its driving commands from the central control unit, and it uses a fischertechnik rechargeable battery pack as its power supply. Now, while each APS factory will ship with one of these AGV, the automated guided vehicles included, if you did wish to add an additional AGV to your factory floor, it can be purchased separately, and of course, we'll talk about that towards the end. Finally, we should, of course, mention the charging station. Now, when the battery of your automated guided vehicle runs low for making its way around the factory floor, it's going to navigate towards the charging dock, where it is automatically charged with a charger with charge monitoring. There are contacts on the floor of the charging station that connect with the AGV with the charging elements, and you're able to recharge the vehicle. So now that you have an overview of the makeup of the APS factory, I'm going to share a short video that's going to provide you with a look at the model in action, along with more details that we haven't covered yet. So I'm going to let the narrator take over in just a second.
Welcome to fischertechnik. Manufacturing processes with digital control and intelligent networking. From goods receipt to production to delivery, every step is automatically controlled, monitored, and documented. The system is based on real industrial components in miniature format: sensors, conveyor technology, robotics, all precise and functional. The dashboard can be used to monitor production at any time, execute order processes, and carry out simulation games. The simulation is perfect for education, study, and training, ideal for vocational schools, universities, and industrial companies. Complex topics such as lean production, agile manufacturing, batch size 1, condition monitoring, and predictive maintenance are clearly conveyed. The focus is not only on technical aspects, but also on economic and organizational aspects. The included digital learning platform integrates didactic accompanying materials with step-by-step instructions, as well as the digital twin. The individual modules are integrated into a higher-level control system via interfaces such as MQTT, OPC UA, or REST API. Connection to ERP or MES systems is possible, as is real-time visualization. This allows process data to be recorded, analyzed, and used for optimization in line with Industry 4.0. The system has a modular design and can be flexibly expanded to meet the requirements of your training environment. Whether manual interventions, automated quality controls with artificial intelligence, or varying production processes, everything can be customized in just a few simple steps. This makes every training situation realistic and tangible. It is also important to provide learners with didactic guidance so that they can learn in a targeted manner in selected subject areas. Together with the Karlsruhe Institute of Technology, we have developed the aforementioned digital learning platform, which contains 4 specific learning modules on the topics of agile manufacturing, the Internet of Things, artificial intelligence, and automation. In the spirit of a consistent learning journey, each learning module begins with a theoretical section. This is followed by a practical section and a transfer task. The digital learning platform is based on a digital twin of the physical plant into which the learning modules are integrated. Also integrated are a production workflow, planner, and a dashboard of the most important production metrics, such as overall equipment efficiency and throughput time. These tools can be used to solve the tasks within the learning modules. The Agile Production Simulation from fischertechnik, your practical learning system for the smart factory of tomorrow. Innovative, flexible, comprehensible.
So, picking up from that, let's just quickly review some of the technical specifications of the APS model. First off, it's a 24-volt power supply unit, 11 amps. The central control, again, is through the Raspberry Pi 4B. Individual modules are controlled with the help of 5 SPS Siemens S7-1200 PLCs, as you saw in the photo when we were discussing that. And additionally, the model includes 3 fischertechnik TXT 4.0 controllers, which are used to control the sensors in the camera, as well as to facilitate cloud access in the WEWA module for quality assurance with AI, and of course, again, for the automated guided vehicle or AGV. It has a WLAN router for WLAN network. Software used on the APS model include SPS programs and structured text that are used for the PLCs. There's TypeScript for central control on the Raspberry Pi. Node-RED for communication between the SPS and the fischertechnik TXT 4.0 controllers. Python for programs on the TXT 4.0 controllers, and TensorFlow for supervised learning and quality assurance with AI. Now, as was mentioned in the video, the APS model includes a cloud-based dashboard which can be used for order control and monitoring of the factory status, as well as for determining key figures. The factory has a modular design with each workstation mounted onto its own baseplate section. This both allows the APS to be broken down into smaller sections for storage, as well as providing flexibility in assembly or for connecting to an additional workstation. Now, when assembled, The Agile Production Simulation model has a footprint of approximately 51 by 73 inches, and it has a total weight of approximately 116 pounds. There is a storage case that's available separately for protecting the model when not in use or when being transported, and we're going to take a look at that in just a minute. And of course, didactic materials are also included. Now, speaking of these didactic materials, I do want to again go back to the digital learning platform touched upon in the video segment. The digital learning platform is a high-performance, immersive learning environment, and it's based on the digital twin of the Agile Production Simulation. This serves as the educational counterpart to the physical model, and the learning tool is used to clearly illustrate the control units, the actuators, and the sensors included on the model, and to demonstrate the full functionality of the APS. The platform offers interactive learning modules on agile manufacturing, IoT, AI, and automation. It enables the simulation and evaluation of highly complex process workflows in agile manufacturing. Now, as was mentioned before, this digital learning platform is a byproduct of the partnership between the fischertechnik GmbH and the Karlsruhe Institute of Technology, the prestigious public research university located in Karlsruhe, Germany. Now, I also wish to emphasize that there are no additional costs or fees associated with this digital learning platform. It is included in the scope of delivery when you purchase the APS. Now, this slide provides a nice breakdown of what exactly is covered by the digital learning platform. Now, as you can see here, users start with an introduction to the Agile Production Simulation, and this begins with an interactive explanation of each of the process modules, as well as of the control units, the actuators, and the sensors. Now, following this, the main instruction is broken up into 4 separate modules, one focused on agile manufacturing, the second on the Internet of Things, or IoT, the third on artificial intelligence, and the last on automation. Each unit or learning module includes the following: theory section, establishing a fundamental understanding of the topic at hand. A practice section. This is where users can simulate and understand the processes being studied with both the physical mode and the digital twin version. Transferability, where students get to see how this knowledge they've acquired can be used in the real world. Now, the digital twin forms the foundation for the digital learning platform. And once again, the educational or exploration mode of the APS is implemented using the digital twin. The digital twin can be utilized to solve tasks in the learning modules. The digital twin can be used to simulate complex challenges in an agile production environment. Among the tools included with the DLP include this workflow planner tool and an analysis tool as well. Flexible, modular, agile, and connected. This is the fischertechnik Agile Production Simulation model. Now, the APS model is the perfect tool to use in higher education for advanced CTE training, labs, and for industrial training. It is an ideal tool for teaching about the future of production. It offers a hands-on learning experience. It provides a safe method for teaching these skills while also offering a tool that replicates both in appearance and in function, those which will be used in industry. It provides a bird's eye view of a working factory, and of course, it offers considerable added value with the digital learning platform. It's also ideal for demonstration purposes for companies involved in areas such as IT and software development, as well as for consulting. Now, in a break with previous fischertechnik factory releases, the APS model has been designed to allow for possible expansion. Now, currently, there are 2 additional modules that are available for purchase separately, which can also be incorporated if one wishes to expand the functionality of the model. The first of these is the annealing furnace, which you see here. The addition of this production module unlocks more learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning module are made available. These cover topics such as introducing new derivatives into production and expanding existing production configurations with an additional process. The module, like most of the modules of the APS, includes its own Siemens S7 1200 PLC, which again has been pre-programmed in structured text. Now, as an FYI, the annealing furnace module has dimensions of approximately 22.5 by 15 by 9 inches, and it has weight of approximately 10 pounds. It is, of course, designed specifically for use in combination with the APS model and is not designed as a freestanding workstation. So, unlike other fischertechnik simulation models that you see, this can only be used with the APS. The second add-on available for purchase, as I touched upon earlier, is an additional AGV, automated guided vehicle, which can also be incorporated into your model. Like the annealing furnace, the add-on automated guided vehicle also unlocks access to further learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning module are made available, and these will focus on agile intralogistics as well as the parallelization and prioritization of the production workflow. The model ships with a pre-programmed fischertechnik Robotics TXT 4.0 controller, and as with the version included in the APS, the programming is again in Python. Now, this can, of course, be used in combination with the APS model, and it is not intended for freestanding use. The dimensions, just to provide that as well, of the model are approximately 10 by 7 by 5.5 inches, and it has a weight on its own of approximately 3.15 pounds. And this concludes the main portion of our overview of the fischertechnik Agile Production Simulation. So let's now look at the cost of each of these items. Hang on a second. Boom, there we go. Okay, the Agile Production Simulation, which again includes the 5 Siemens S7 1200 PLCs and 3 fischertechnik TXT 4.0 controllers, as well as access to the digital learning platform with the digital twin. The cost for the APS is $35,175. The APS add-on module, the annealing furnace, which again includes its own Siemens S7 1200 PLC, and of course unlocks additional didactic content in the digital learning platform. The cost for this model is $4,439. The automated guided vehicle, the AGV add-on, which again also unlocks its own additional didactic content in the digital learning platform. The cost for this model is $2,589. And there is one more thing to cover very quickly, and that is the storage and transport case designed especially for the Agile Production Simulation model. Now, as the APS model is obviously a substantial investment, this is a great option to help protect the model when not in use, and of course, when you need to transport it safely. The case itself has an aluminum case maker profile with plastic plates. Now, each of the 2 separate case sections has steel tilt handles and an angle protection corners for additional stability. There are also straps and internal zipper pockets for storing cables, cords, workpieces, and other accessories. The lower section of each case is lined with hard foam, while the upper sections have some foam to help cushion the various work modules when in storage. The dimensions of this case are approximately 48 by 32 by 29 inches, and it has a weight of approximately 75 pounds unloaded. And when the APS model is loaded into the case, the total weight is approximately 190 pounds. Now, please note that even when the model is kept in the storage case, if you are transporting this model, it must always be shipped flat as freight on a pallet. Now, the cost for the storage case is $4,799 each, but I will mention something in this webinar. There is a special offer that is in place right now, and in order to take advantage of this offer, you have to place an order for the APS, the Agile Production Simulation model, on or before July 27th of this year. So A little under a month that's left in this offer. We started in June, but it extends through, like I said, July 27th. If you purchase the APS model during July, up until again July 27th, you will receive the storage case with the model, a $4,799 value, absolutely free. So keep that in mind. If you need to know more about that, you can contact me and I'm going to give you the information on how to do that. So if you did have any questions, this is where you could use the webinar chat window or the Q&A window, both of which can be located on the Zoom toolbar. But if I don't see any typing going on, I am just going to move right ahead here. So, if you would like to take the next step, that could be requesting the full color fischertechnik Higher Education Industry Guide and APS fact sheet. I can send you those in PDF versions or printed versions, depending. If you'd like to get a quote, if you would like to speak with your dedicated educational representative, depending on which state you're in, or if you're a commercial customer, you could speak with me. In any case, you can call us here, Studica. Our phone number toll free is 888-561-7521. If you have just generic inquiries about the model, getting a quote, what have you, you can email us at info at Studica, Studica.com. If you have questions for me specifically about anything I mentioned, anything that you would like to know more about, any documentation you need to see, any questions about anything fischertechnik related, whether it's the model we looked at today, other models, other kits, what have you, you can contact me directly, lance.zurek, lance.zurek @studica.com. So on that note, thank you very much for taking the time to attend today's presentation. We look forward to hearing from you soon. Have a great holiday weekend, and we hope to see you soon.